We are going to do another two-chair question. We're going to draw the two chairs for cis, 1 isopropyl, 4 nonnyl cyclohexane. So same strategy to start. You draw your first hexagon. Oh, they're nice and thick, these lines, huh? And didn't quite meet. And over here, not quite long enough. There we go. Inside, inside, finish, finish. And we're gonna go clockwise, 1, 2, 3, 4, and clockwise from the bottom right, 1, 2, 3, 4. Ladies and gentlemen, if you choose the top right to be carbon 1 in both, you will get half credit maximum. You can't even get that because you're going to be comparing the same molecule. You won't even get half credit. So remember, when he did the sigma rotations, he was trying to show us with the toys. It was not clear at all. Any carbon angle that used to be up in chair number 1 got rotated to a down position in chair number 2. And I'm going to draw the 4 bonds on carbons 1 and 4 only, and start with blue. Axial straight up on 1, straight down on 4. They follow the carbon angle. Straight down on carbon 1, straight up on carbon 4. They follow the carbon angle. We'll do our equatorials all in red, and we won't highlight anything in the ring. We're not going to highlight the parallelness. But they are parallel. This red is parallel to the 2, 3, and this red is parallel to the 5, 6, et cetera, et cetera. Oh, why did I go to carbon 2? That's a great question. Why the heck did I put that there? There's nothing in 2 in this question. Probably from left over from last question, right? There. Do we agree that's parallel to the 2, 3?
Wait, did you?
At first I did, because I don't need to do anything on 2 in this question.
You got number 1 right here. Shouldn't
Axial straight up, equatorial slightly down.
yeah, and then the other one.
Axial straight down, equatorial slightly up.
No, the other, second.
Axial straight down, equatorial slightly up. Axial straight up, equatorial slightly down.
Shouldn't axial be up?
Oh, no, axial's only up if the angle is up. There, the angle is up. Axial's up. Here, the angle is down. Axial's down.
Okay.
That's how you predict which way the axial goes. She may have been confused because our first example had both axials up. Yeah, maybe. No, I don't even think that's true.
No, they weren't.
No, they were
I
not.
was like, they would be the same since they were the same numbers.
Okay, and cis isopropyl 4 nonnyl, just a little quick sketch of the molecule. You're not going to get any points for your quick sketch, by the way. I'll go wedge, wedge. Isopropyl on a wedge, that means H on a dash, right? And on carbon 4, cis means wedge, wedge. Nonnyl, 1, 2, 3, 4, 5, 6, 7, 8, 9. And H on a dash. So we're going to convert that to chairs. Remember, wedge equals up, dash equals down. So the wedge isopropyl is which of these 2 bonds on carbon 1 over here? Blue or red? Up. Which is one? Blue or red? Blue. So isopropyl right there. H here. Carbon 4. The nonnyl is up, correct? It's on a wedge, right? Red is up here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Verify that. 1, 3, 5, 7, 9. H down. Labeling, since we're here. Green, no, purple. Ax. Once again, you'll be told Ax is okay and EQ is okay. And EQ. And we haven't done the next one. Which of these two gets the isopropyl on carbon 1, red or blue? What stays the same? What changes?
Let's do red.
Red, because axial has to become equatorial. If you chose blue, straight out wrong. We don't like straight out wrong. We like straight out right, because every axial has to become equatorial, and every equatorial has to become axial. 1, 2, 3, 4, 5, 6, 7, 8, 9. H. And wait, did I do that right? No! I lied. Up stays up, down stays down, equatorial becomes axial. So why the heck was I drawing it on the equatorial? Explain that. Equatorial becomes axial. That's this one, right? 2, 3, 4, 5, 6, 7, 8, 9, and H. Axial is now sorry. Oh boy. Won't even let me get the eraser. I wanted that to be an embarrassing thing. There's a story in the morning section about the student. I don't know why. It was really sad. They made AQ one of the answers in their mind. I told the story this morning. And I wrote AQ there by mistake. The story was in my mind. I can't give them anything. They mixed up the two short forms. They used half of each. Oh, it's a sad day for me and the student. Okay, yeah. Which chair are we circling? First one or second one? Which group's bulkier? The nonyl or the isopropyl? The isopropyl. It has a branch immediately off of the ring. That's bulky when you have a branch immediately off the ring. The nonyl has no branch at all. So where do bulky groups prefer to be, axial or equatorial? Equatorial. Please pick which molecule has the isopropyl on the equatorial. You labeled it. A second. And your explanation is going to match pretty much the one from before. C was the circle. D, the bulkier isopropyl. Group. Whoa. It's not moving for me, sorry. Group avoids what?
Diaxial.
Okay, I'm gonna give you 2.5 out of 3. You gotta tell me, when is diaxial repulsion a negative thing? Not when the groups are on adjacent carbons. It's not when the groups are on carbons 1 and 4. We forgot.
Yeah.
1, 3.
Wait, is it always one thing?
There's no negative interaction if it's 1, 4. Here, the worst drawn chair ever, but fast. Are those H's even remotely close to each other?
No.
And they're axial? That's like the best interaction there. They're 180 from each other. That's not a bad thing. Are the equatorials in a bad situation if one is here and one is here? No, they're 180 degrees from each other. 1, 2 diaxial is not a thing. 1, 4 diaxial is not a thing. We don't talk about things that aren't things, right? We talk about that one because this picture occurs only when they're on 2 carbons away from each other. Look, they are physically close in space. You can see them. Okay? That's the negative interaction that you have to know. Okay, so don't give me any 1, 4 diaxial or 1, 2 diaxial. Only 1, 3. And that's that. Want the whole picture. And adios.